Well, by now you know quite a bit about your ADF, so let's now look at the techniques you'll use flying IFR with it. First, remember that since an ADF has no off flag or other warning device to tell you that you've lost the signal, you'll want to listen to the identification audio while you're using ADF for navigation. Loud enough to hear it if it stops, but not so loud as to be distracting. Along those lines, if your ADF needle is rock solid and doesn't move at all, don't get smug thinking that it's your superior skill keeping it that way. By its nature, ADF should almost always have some needle movement. So if your needle doesn't move, you'll want to check that you have your ADF correctly set up. Then make a slight turn to see that the needle moves as it should. As you've seen, homing is one way to navigate with an ADF, but only if you want to go to the NDB, and only if you're not concerned about the path you take to get there. However, there are times when terrain and traffic make flying a random path in the clouds hazardous. So let's look at a far safer and more efficient way to use an ADF, one that will get you to and keep you on a specific NDB bearing, such as a course on an NDB approach. This way, you know you will be clear of obstacles and traffic. So let's talk about how to intercept and track a bearing. Let's say ATC was giving you vectors to the 060 bearing to an NDB. But as luck would have it, you've lost communications with ATC, and now you need to get yourself to that 060 bearing to the NDB without their help. First of all, you'll need to know where you are in relation to that bearing. I find it sometimes easier to visualize a situation like this if I convert the bearings so they're both from the station, so that I can think of them the same way I'd think of radials from a VOR. Of course, you already know that the one you want to be on, the 060 bearing to the station, is the same as the 240 bearing from the station. But what bearing are you located on? To learn that, first you want to make sure your ADF card agrees with your heading. Then, to find out the bearing you're on, all you have to do is look at the number the needle points to. Your heading is currently 180 degrees, so rotate your ADF card to 180 to match your heading. Let's say that the head of the needle shows your magnetic bearing to the station to be 090 degrees. That means the tail of the needle tells you that you are on the 270 degree bearing from the station or west of the station. So now all you have to do is turn to some heading so that you will intercept the 060 degree bearing to the station somewhere southwest of the NDB. There must have been some reason why ATC wanted you on that bearing, and if you turn southeast to intercept the 060 degree bearing to the NDB at a 90 degree angle, you'll get there most directly. 60 degrees plus 90 degrees equals 150 degrees. So you turn to a heading of 150 degrees and fly directly to the 060 degree bearing. And of course, you'll need to remember to reset your ADF card to match your new heading every time you make a turn. As you fly to the southeast, you'll gradually see your bearing to the station move from 090 degrees counterclockwise towards the 060 degree bearing. As you approach the 060 degree bearing, you'll want to gauge how fast the needle is moving and lead your turn so as not to overshoot the bearing. If you had absolutely no crosswind, tracking an ADF bearing would be the same as homing. You just turn to put the head of the needle at the top of the indicator and it would stay there. But as you and I both know, no crosswinds only happens in fairy tales. In real life, you can expect that there will be some crosswind and that you'll have to crab into the crosswind to track your desired course. And if you know where the wind is from, you'll set up your crosswind correction right away. But let's assume in our example that you don't know where the wind is from when you intercept the 060 degree bearing. So you initially turned to a heading of 060 degrees. After a few minutes, you realize you've been blown just a little to left of course, and your bearing is 065 degrees. By the way, an ADF needle sometimes swings around a lot. If you have that happen, just visually average the swings. So here you are, 5 degrees off course, which may not seem like a lot, but now is the time to start correcting for it. So you really want to do two things. One, you want to get back on course. And two, you want to set up a crosswind correction so that you don't drift off course again. In order to do this, it's helpful to think of turning towards the needle. In other words, if the needle is to the right of your desired bearing, you turn to the right. If the needle is to the left of your desired bearing, you turn to the left. One rule of thumb is to double the needle into the wind. In other words, if you are 5 degrees off course, you want to make a 10-degree correction back to course. The amount of correction you make will depend on how fast you drifted off your course and how close to the station you are. Let's try a 10-degree correction to begin with. This means that you'll now take up a heading of 070 degrees. After you make your turn, rotate the ADF card to match your new heading. Now, as soon as you're established on your new heading, watch to see if your bearing changes. If you drift further to the left, the needle moves further to the right, you know you need to make even more of a crosswind correction. If you move back to your desired course, you know your correction is working. The key is to make small corrections, especially when you're close to the station. Then, if your corrections don't get the results you want, make further small corrections. When you get back to your desired course, set up an estimated crosswind correction and watch to see the results. Now, you'll know that you've crossed the station when the needle swings rapidly from in front of the airplane to behind it. Let's say you now want to track the 025 degree bearing from the station. As soon as you pass the station, you'll need to start a left turn. Due to reaction time, there will be a delay between when you pass the station and when you start your turn. So you'll need to set up an intercept angle to get back to the 025 degree bearing from the station. Since you are close to the station, a 20-degree angle ought to work fine. You might take up a heading of, say, 005 degrees. When you first start that left turn, your bearing from the station will be about 060 degrees. When you are flying a bearing from the station, you use the tail of the needle to determine your bearings. As you fly to the north, your bearing will gradually move toward 025 degrees. As the tail of the needle approaches 025 degrees, you will want to turn to follow that course. Once again, you will lead that turn based on the rate of needle movement. Since you already have a rough idea of the wind direction, you can take up a heading that you think will correct for the wind and allow you to follow the course. To start, you might try 5 degrees correction for a heading of 030 degrees. Then, just as you did when you were flying towards the station, you will want to make very small corrections quickly and keep checking the results. When you are tracking away from the station, it is helpful to think of pulling the tail of the needle with you. For instance, let's say that you've drifted about 5 degrees to the west of your course. You must have a stronger crosswind component on this heading. So now your bearing from the station is 020 degrees. This time the tail of the needle is to the left of your desired bearing, but you have to turn to the right to pull the tail of the needle back to the course. The same rules of thumb will apply. You need to return to course 025 degrees and set a crosswind correction. And again, you'll determine the number of degrees you need to turn by how fast the needle moved and how far you are away from the station. When you get in the air and gain some experience with ADF, you'll find that you have gained a new tool that can help with position awareness on every approach. Plus, your new skill just might help you get into some remote airport on a dark and rainy night.